Lecture 4 of 4, Subtopic 5.2, Composite Functions. At the end of the lesson, students should be able to represent a composite function using an arrow diagram. Find composite function. Find one of the functions when the composite and the other functions are given. So what is composite function? So let's look at the box below. So composite functions are functions arise as a result of a combination of two or more basic functions. So the resulting composite function is denoted as g of f, defined by g of f in bracket x. That means g bracket fx. Okay, so you can read through how to read the g of f. Can be say as g circle f, g round f, g composed with f, but we are going to use g of f. Okay, so let's look at the arrow diagram. So if you have, this is the x, the set x, set y, and set z. So f will be from x to y, g from y to z. Okay, so we have f from x to y, and then we have g from y to z. Okay, so this is g of f, meaning we are doing f first, then only g. So this is the g of f. G of f. Right. Right, let's look at example 21. Given that the elements of set A, B, C, and D are defined as follows. So this is set A, this is set B, this is set C, and D. Okay, if F is from A to B, G from B to C, and H from C to D. So where the function fx is given as square root of x plus 1, and the gx is x squared, and hx is 2x minus 1, where x elements of real number. So similarly for gx. So represent the composite function below using arrow diagram. So write down your gx first. So gx will be gx is x squared. So we have fx will be square root of x plus 1. Okay, so let's draw the arrow diagram. So this is your set, the first set, second, third. So we know already that f is from A to B, and g is from B to C. So meaning this is your, we want gf. So meaning we do fx first. We do fx first. So meaning A to B. So this is your f. And then from B to C, this is C. That will be your G. Okay, let's write down the elements of A. So that is negative 3, negative 2, negative 1, 3, and 8. And then B is 0, 1, 2, 3, 4. And then C is 0, 1, 2, 4, 9, 12. So using fx, where is your fx? So write down fx here. Fx is square root of x plus 1, but x is greater equal to negative 1. So if you look at the set A, so we are going to use only greater than equal negative 1. So that will be negative 1, 3, and 8. So if we substitute x to be negative 1, right? So what is your fx? So x equal to 3, what is your fx? If x equal to 8, what is your fx? So when we substitute fx to be negative 1, we get 0. When we substitute 3, we get 2. When we substitute 8, we get 3. So next, we get negative 1 to 0. Draw the arrow, and then from 3 to 2, and then from 8 to 3. Right, so we have 0, 2, and 3 here. So next we're going to do G from B to C. So our function g is x squared. So gx is x squared. So when x is 0, what is our gx? When x equal to 2, what is our gx? When x equal to 3, what is our gx? So substitute into the function, we get 0. 2 squared is 4. 3 squared is 9. So draw the arrow. So 2, 0. And then from 2 to 4. And then from 3 to 9. Right, so let's highlight it. Okay, that is our answer. So hence, f of x, that will be 0, 4, and 9. Right, same goes for b. So let's look at b. We have hg. So hg, so write down what hx is. So hx is 2x minus 1. And then our gx is now x squared. So we have hx is from b to c, right? Now hx is from c to d. Okay, so c to d. And then we have gx. Gx is from b to c. So we are going to do g first. hgx, that will be h bracket gx. Okay, let's draw the arrow diagram, the bean. So we have 1, 2, and 3. So this is the first one, which is gx, meaning from b to c. And then we have hx from c to d. So let's fill in the elements of set B. Right, these are elements of set B. So set C and then set D. Right, again, so write down our gx. So gx will be x squared. So x elements of real number. So let's find when x is 0. So we have gx to be 0. When x is 1. When x is 2. When x is 3. And then when x is 4. So we have gx to be 1, gx 4, gx 9, and then gx to be 16. Okay, I'm going to use blue color now. Okay, from 0 to 0, and then 1 to 1, 2 to 4, 3 to 9, 4 to 16. We don't have any 16. So we are not using 16. Okay. From this, okay, let's do h. So our hx is, okay, let's use black again. So our hx is 2x minus 1. So when x is 0, when x is 1, when x is 4, when x is 9. So what is our hx? Right? So we substitute into the function. When 0, we get negative 1. 1, we get 1. 4. 4 to 8 minus 1, we get 7. 9 to 18 minus 1, we get 17. So hence, okay, I'm going to use blue now. So from 0, we get negative 1. And then from 1, we get 1. 4, we get 7. And 9, we get 17. So hence, the answer will be hg x, that will be negative 1, 1, 7, 17. Example 22, if fx equal to sert x, square root of x, when x is greater equal to 0, gx equals to 1 plus x, x elements of real number. Find f of g. So f gx, Okay, rewrite in brackets, proper brackets, and then substitute your gx. Gx is 1 plus x, and then substitute into function f, so square root of 1 plus x. So this is your fg. So make sure we apply what we learned before. So under the square root, 1 plus x must be greater equal to 0. So x greater equal to negative 1. So this is your answer. So let's look at b. We have f squared x. So that will be f of fx. So substitute into your fx. So f, we get square root of x here. And then square root of x. So change the square root into index. So we get x power of half, and then power of half outside. So that will be x power of 1 over 4. So that is your f squared x. So let's look at c. We have g of f. So this is g, fx inside. So our fx just now is third x. And then gx is 1 plus x. So substitute your fx, that will be third x, and then we have 1 plus third x. So for this case, x greater equal to 0. So this is your gf of x. And then d, same thing. So this is g of gx. So gx is 1 plus x. So substitute again. So 1 plus x. So we have 2 plus x. So this is your g squared x. Right, example 23. If fx equal to 3x, where x elements of real number, gx equals to 2x minus 1, and hx equal to x squared. So find gf3. So we need to find gf of x first. So g bracket fx. So substitute the function of fx, which is 3x, and then substitute 3x into g. So we have 2, 3x minus 1, so we get 6x minus 1. So this is your gf of x. So gf of 3, so substitute 6, 3 minus 1, so we get 17. So let's look at b. So we need to find f gh of x. So fg, so put in bracket, so g and then hx. So fg hx is x squared. So substitute into g. So we have f 2x squared minus 1, and then substitute into f. So we get 3 times 2x squared minus 1. So fghx equal to 326 squared minus 3. So substitute fgh2. So that will be 6 times 2 squared minus 3. So 6 for 24 minus 3. So 21. So next, look at c. So same thing. So find GHF of x first. So use proper brackets, GH and then fx. Right? So GH, your fx is 3x. Substitute into h. So g, we have 3x bracket squared. So then substitute into g. So we have 3x squared minus 1. So GHF of x, that will be 3 squared 9, 9 to 18x squared minus 1. So substitute 4. So GHF 4. So 18, 4 squared minus 1. So we get 287.
Example 24. The function f, g and h are defined by fx, gx and hx. Show that f squared equal to x. So first, we must find the composite function for f of fx, and then we must show that the answer is x. So substitute f into f means 2x minus x, and then 2 minus x we substitute with 2x. So the final answer is x. So we can get the answer is equal to x. Same with the question. Okay. Question number B. Find an expression for g squared and state for which two values of x it is undefined. So first we must find g squared. G squared means g of g. First we must substitute g. So the function g is 3 over x plus 1. And then we substitute again function g with g. So we substitute x with 3 over x plus 1. And then we simplify the fraction. So 3 plus x plus 1 over x plus 1, or we can write it as 3x plus 3 over x plus 4. So this is g of g, or g squared. And then the question given then, find the value of g squared when x is undefined. Means, okay, so how to find g squared x is undefined? We noted that g squared x is rational function. So for rational, we know that the denominator must not equal to 0. Okay, for this question, we must find undefined, so we must equal to 0. So we can get x equal to -4. And then another one, from g, we noted that 3 over x plus 1. So also the denominator must not equal to 0. So x equal to -1. This is two values when g squared x is undefined. Therefore, x equal to -1 and x equal to -4. And the last question, question C, solve the equation h cubed equal to x. So question C, h cubed equal to x, and then we must find the value of x. So first, we know that h of hx equal to h cubed. So first we substitute h into h squared. So we can get 2x minus 1. And then substitute again into x. So we can get 2 minus 1 equal to x, mean 2x minus 1. And then we simplify first. So for x minus 3. And then we substitute 4x minus 3 into into h again. So we can get 2, 4x minus 3 minus 1 equal to x. And then we simplify and solve the equation. So we can get x equal to 1.
Right, example 25. So we are given gx to be square root of x minus 1. Determine function fx if g f of x is 2 over x. So we will start from g f of x as 2 over x, and then gx to be square root of x minus 1. So g fx equal to 2 over x. So we are going to substitute. So I'm going to use different color now. We are going to substitute fx here inside this, inside g. Okay, so we will use square root of fx minus 1 equal to 2 over x. Alright, so how do we eliminate the square root? So we are going to square both sides. So we will have fx minus 1 equal to 4 over x squared. So hence fx will be 4 over x squared plus 1. So meaning x cannot be 0. Example 26. Given that gx equal to x squared plus 1 and gf of x equal to x squared plus 4x plus 5. So we will start with gf of x equal to x squared plus 4x plus 5. So we are going to use proper brackets on the left side, alright, so that we can see what we are going to substitute it with. So now, instead of x here, instead of x, we're going to substitute fx. So substitute into the function, so we get fx bracket squared plus 1 equal to x squared plus 4x plus 5. So bracket fx squared equal to x squared plus 4x plus 4. So 5 minus 1, you get 4 there. So then the right side, we use completing the square. So we get x plus 2 squared. So this is your fx bracket squared. So bracket squared here, bring it to the right side, we get plus minus square root of x plus 2 squared. So you have the square root and you have the square there. So that eliminate the square root. So we get plus minus of x plus 2. So hence, we have two functions of fx. So fx equal to x plus 2 or fx equal to negative of x plus 2. So that will be negative x minus 2.
Example 27. Given the function f and then determine the function g if gf is equal to x squared minus 6 plus 1. For this question, the given function is the inside of the composite function. And the question is how to find gx. So gx is outside. If outside, we use let method. Okay. So we just substitute fx into gx like this, and then we let whatever inside the gx. So we let, for example, u as x minus 2, and then we make x as a subject. What we are going to do is we just substitute x on the right side. And then we substitute g u equal u plus 2 squared minus 6 u plus 2 plus 1. And then we can simplify the answer. So the final answer is u squared minus 2u minus 7. So we substitute again u with x. So we can get x squared minus 2x minus 7. Example 28. If fg equal to 4x squared minus 2x plus 1 and gx 2x plus 1, find the function of gf. Hence, find the value of x that satisfy fg equal to gf. So first, we must find the function of f so that we can find g of f. So the given function is gx equal to 2x plus 1. And then another one is f of g equal to 4x squared minus 2x plus 1. And then we must find the function of f. So f is outside. Outside is outlet, let. Use the let method. So f, we substitute g to x plus 1 equal to 4x squared minus 2x plus 1. And then we let whatever inside of f. So let u equal to 2x plus 1. And then make x as a subject. So you can get u minus 1 over 2. So we can get fu equal to 4 u minus 1 over 2 squared minus 2 u minus 1 over 2 plus 1. And then we simplify the answer. So 4 u squared minus 2u plus 1 over 4 minus u minus 1 plus 1, or u squared minus 2u plus 1 minus u plus 1 plus 1. So the final answer is u squared minus 3u plus 3. So we can get fx equal to x squared minus 3x plus 3. And then we must find g of f. So g of f is equal to g x squared minus 3x plus 3. And then substitute into g. G is 2x plus 1. So 2x plus 1. So substitute the inside function. And then we can simplify. So the answer for g of f is 2x squared minus 6x plus 7. And then the question given that find the values of x that satisfies fg equal to gf. So fg is equal to gf, means fg is 4x squared minus 2x plus 1. And g of f is 2x squared minus 6x plus 7. And then we simplify to get the value of x. So we can get 2x squared plus 4x minus 6 equal to 0. Or we can simplify x squared plus 2x minus 3. And then we factorize, we can get x plus 3, x minus 1 equal to 0. So x equal to negative 3 or x equal to 1. For last subtopic, 5.4 exponential and logarithmic function. Example 29. The function g is defined by gx. Determine the function of f if g of f equal to exponent x. So the given function is gx equal to set x plus 1. And then g fx equal to exponent x. So the question is inside. So for the inside function, we should use substitute method. So we just substitute fx into g function. So we can get sert fx plus 1 equal exponent x. So now we can make fx as a subject. So we can get fx plus 1 equal to exponent 2x. And fx is exponent 2x minus 1.
Right, example 30. So given that fx equal to ln of 2x and gx equals to exponent of 3x, determine g of f. So gf inside, so substitute your fx. So that will be ln of 2x. So substitute into g's, we get exponent of 3 ln of 2x. So by using the properties of index, so e or properties of log, so we get ln of 2x cubed. So exponent ln, we get 2x bracket cubed, that will be 8x cubed. Right, so write properly, we have the gf of x to be 8x cubed. Okay, so let's look at b. fg, so same thing, so this is f, gx for the inside function. So f, so gx is exponent of 3x, so substitute into fx, so ln of 2 times exponent of 3x. Okay, so we use the laws of logarithm, so ln 2 plus ln of exponent 3x. So we have ln 2 plus 3x ln e. So that will be ln 2 plus 3x. Okay, so fg of x, that will be 3x plus ln 2. And then c, determine hx if hgx equal to x squared. So h, substitute gx, exponent of 3x equal to x squared. And then substitute into hx. We don't have any hx, so we're going to let let's say y equal to exponent of 3x. So meaning 3x equal to ln y, so x is ln y divided by 3. So we're going to substitute now, so meaning hy equal to ln y over 3 bracket squared. So this is in terms of y. So we have to change it into x. So hx equal to ln x over 3 bracket squared. So that will be ln x bracket squared over 9. So that is your hx. Right, example 31. Okay, the function f and g are defined as fx equal to square root of x minus 2, gx equal to x over x minus 2, where x cannot be 2 respectively. A, state the domain and range of g. So A, we have the function gx to be x over x minus 2, where x cannot be 2. So as what we learned before, so this is actually the domain of your g. So you can state directly, domain of g is real number except 2. Okay, next we're going to find the range. So we're going to let y equal to fx, no, y equal to gx. Okay, so y equal to x over x minus 2. So cross multiply, so get y x minus 2 equal to x, xy minus 2y equal to x. So that will be xy minus x equal to 2y. So factorize your x, so y minus 1. So x will be 2y over y minus 1. So for this case, we have y minus 1 cannot be 0. So y cannot be 1. So that is your range. So range of g will be real number except 1. Right, next let's look at B. Find the inverse function. So we're going to use f of f inverse of x equal to x. Okay. So we're going to substitute f inverse into the function of fx. So square root of f inverse of x minus 2 equal to x. So to eliminate the square root, again, we can do squaring both sides. So here x, we get the square root of f inverse of x minus 2. So f inverse of x minus 2 equal to x squared. So f inverse of x equal to x squared plus 2. Okay. So we are required to determine its range. So knowing that range of f inverse equal to domain of f. So if you look at the function of fx, we are given square root of x minus 2. So meaning that is x minus 2 must be greater equal to 0, x greater equal to 2. So the domain will be 2 to infinity. So hence evaluate f inverse of g3. So we need to get f inverse of gx first. So we're going to substitute f inverse. So your function gx is x over x minus 2. So substitute into your fx, or f inverse, sorry. So x over x minus 2 squared plus 2. So this is your f inverse of gx. Okay, so that will be so we just substitute f inverse g of 3. So that will be 3 over 3 minus 2 squared plus 2. So that will be 11.
For example 32, the function f and g are defined by fx and gx. Find f of g, hence deduce f inverse. So the question is fg equal f, substitute g into f. G is 3x plus 5 over 2 minus x. And then substitute into f. So you can get 2, 3x plus 5 over 2 minus x minus 5 over 3x plus 5 over 2 minus x plus 3. And then we simplify the answer. So we can get 2 times 3x plus 5 minus 5 times 2 minus x over 2 minus x over 3x plus 5 plus 3 times 2 minus x over 2 minus x. Because of the denominator are equal, so we can eliminate. So the answer is 6x plus 10 minus 10 plus 5x over 3x plus 5 plus 6 minus 3x. And simplify the final answer, we can get 11x over 11 or equal to x. From this question, we know that fg is equal to x. And from the previous, we noted that if f of f inverse equal to x, thus gx is equal to f inverse. From this one, we know that f inverse is equal to gx. Gx is 3x plus 5, 2 minus x. So from this inverse, we must find the domain and range for the question B. So how about the domain? The domain of f inverse is equal to all real number except 2. And for the range of f inverse is equal to all real number except negative 3. Because we can get 3 over negative 1. That's why we can get all real number except negative 3.